College Algebra, Chapter 4, Section 3, Quadratic Functions and Their Properties. Objective 1. Graph using transformations. Now remember what transformations are. They're shifting things around, stretching and compressing. So if we write our function this way, a and then x minus h squared plus k. We know that, well, maybe you don't know, but k will move this up and down. This is a vertical translation. H moves it right and left. It's inside the squaring function. A is outside the squaring function, so it'll either stretch or compress vertically. So A and K are vertical. H is horizontal. We could put, I guess, a coefficient here, but we could also factor that out, and that would be part of A. So we usually don't do that inside here. So just right and left translations, up and down translations, and the vertical stretch or compression with the A. So if A is greater than 1, then it's a vertical stretch. Between 0 and 1, then it's a vertical compression. If it's negative, it flips vertically. H, this subtraction is important, because if H is positive, then you're subtracting x minus whatever. Moves it to the right. If it's x plus some number, then it moves it to the left, sort of opposite what you think. But adding k, you move up. Subtracting k, you move down. So let's see if we can graph something like, I don't know, 2x minus 3 squared plus 4. So this moves it 3 to the right and 4 up. Remember where the reference point is for these. So 3 to the right and 4 up. This is the new spot for the reference point. 2 means it's going to be vertically stretched, so it's going to be skinnier than normal, but it's still a parabola. If 2 were negative, it would open down. If 2 were 1/2, it would be a little fatter, so to speak. If you added 3, it would go left 3 instead of right. If you subtracted 4, it would go down 4 instead of up. So you should be able to find that new reference point by using the H and K. That is called the vertex. And so that's one of the things you need to recognize. You're moving the reference point, the vertex, in this case, right 3, up 4. In fact, that is the second objective. Objective 2 is to recognize some things in these graphs. Identify the vertex, the axis of symmetry, so if we're able to graph this, it's easier to see what these are. Let me put it in the first quadrant here. In fact, we're going to talk about several things. Every parabola has a focus inside. It also, same distance away, has a directrix. Those weren't asked for here, but I thought I should mention them just so you can keep that in mind. The vertex is that point right there, either the lowest or the highest point. the distance from the vertex to the focus and the vertex to the directrix is exactly the same. The axis of symmetry goes through the focus and the vertex because it is symmetric right to left. So every point on the right has a mirror image over on the left and vice versa. So the axis of symmetry goes straight through that vertex vertically through the focus and the vertex. It's perpendicular to the directrix. So how do you find those? Well, finding the vertex is the key. How do you find the vertex? There is the form that we talked about before, y instead of fx, a times the quantity x minus h quantity squared plus k. The vertex is easy to find. It is hk. Subtraction is important. This addition is important. That would be the vertex. Because these are parabolas that open up or down, the axis of symmetry is always vertical through the vertex. And therefore, the axis of symmetry, the equation of a vertical line, is x equals something. In this case, it'll be x equals h. But suppose you had something else that wasn't as easy to see. So it's ax squared plus bx plus c. This form of the quadratic. You can put it in vertex form, but it's just as easy to look at the opposite of b over 2a for the x-coordinate. Take the opposite of the middle term's coefficient, divide it by twice the leading coefficient. Plug that back in to find out what y is, and that is your vertex. And that means that the axis of symmetry is this x-coordinate, the negative b over 2a. So, these a's are the same. That's sort of important. But b is sort of hidden inside this x minus h quantity squared. So is c. C is also the y-intercept. You'd have to find out what the y-intercept is for this vertex form. So you can do a lot of things like that in order to graph them. In fact, how do you find the x and y-intercepts? The y-intercept is when x is 0. That's why y equals c. The x-intercepts are when y is 0. And so you solve for 0 equals ax squared plus bx plus c. Or 0 equals a times the quantity x minus h squared plus k. But that's the next objective. Graph using the vertex, axis of symmetry, and the intercepts. That's symmetry. I'm going to run out of room. So, let's see if we can do this. I'm going to pick, I don't know, 3x squared minus 5x plus 1. I don't know if that's going to work or not. 3x squared minus 5x plus 1. Now, this one's a little hard to see, but we can say that I know what a is. A is 3, b is a negative 5, and c is equal to 1. So, the x-intercepts I'll have to figure out. But the y-intercepts are pretty easy because there's only one. If x is 0, y is 1. The vertex, it's the opposite of b, so it's a positive 5. over 2 times a, 6, and then plug that in to get y. So let's see, it's 3 times 5/6 squared minus 5 times 5/6 plus 1. Let's see, this is 25/36, 3 times that. And this is 25/6 plus 1. Times 3, so it's 75/36. Now, in order to get a common denominator so we can combine these, I've got to multiply by 6. What is 6 times 25? Well, what is 6 quarters? 150 cents. That'll be 36, and then 36 over 36 is the same as 1. So this is 75 and 36, 111. 36 minus 150. 36, which is a negative 39. 36. My goodness. So let's reduce that. Divide by 3. We get a negative 13/12. So the vertex is 5/6 and negative 13/12. Not real nice, but we just sort of picked this off the top of our head anyway. The x-intercepts, we have to solve this, and I think I'm going to use the quadratic formula. So x is the opposite of b, 5, plus or minus the square root. B squared is 25 minus 4ac. 4 times 3 is 12, and then 1, all over 2a, which is 6. So x equals 5 plus or minus the square root of 13 over 6. Not really nice numbers at all. So how do we graph all this? Well, we need to plot some of this stuff. The vertex, and let me write this down so I can have it available. Okay, here's the information with a little more room. Now, I didn't mention before, but it opens up because a is greater than 0. It's positive. If a were negative, then it would open down. So we are at 5. That's positive and negative. So we're in the third quadrant, sort of. So we're going to go over 5/6, which is like 1 1/6, right? And down 13/12, which is like a negative 1. So 5/6 and a negative 1 someplace here. That's the vertex. It opens up. So at 0.23, like 1/4 of sort of, almost, and 1 1/2, someplace here. Oh, 5/6 should be over here a little bit. Okay, that makes more sense. The y-intercept is 1, so it looks something like this. Not that thing. 5/6 is less than 1. And like negative 13/12, a little bit more than a negative 1. So all of these should fit, and if they don't, like that vertex was a little off before, it's because I was plotting, I guess, 6/5 instead of 5/6. So this is how you can graph it using the x-intercepts, the y-intercepts, the vertex, which way it opens, and that should give you enough information, along with the axis of symmetry through the vertex vertically. These should match. So, what is the last objective? Objective 4. We want to find maximums and minimums. If a maximum or a minimum occurs, which it will for this, it will be at the vertex. If this opens down, it'll be a maximum. If it opens up, it will be a minimum. But all we need to find is the vertex. Now the vertex tells us two things. The x tells us where things occur, and the y tells us how much. So if we take a look at some of these, on page 302, number 24. We're supposed to graph the function starting with y equals x squared, then using transformations. F of x equals 2x squared plus 4. So f of x is 2x squared plus 4. So what did we do to x squared? X squared is just the parabola that opens up. We didn't move it right or left because there's nothing added or subtracted to the x. We did move it up 4, and we did multiply by 2, which made it skinnier. So we moved it up 4 and made it skinnier. Boy, not real good at drawing those curves. Does this make sense? Okay, what about number 34? Graph each function. Let's go to another screen. Number 34. 2/3 x squared plus 4/3 x minus 1. So if we want to use transformations here, we might have to rewrite this. In fact, we will. We're going to have to write it in that form: f of x equals a, x minus h quantity squared plus k. That means we've got to complete the square on this. So what do we do first? Well, I'm going to put the 1 on the other side, this negative 1. I'm going to factor out a 2/3, and then I'll just have x squared. But I've also got to take care of this. If I divide this by 2/3, what is 4/3 divided by 2/3? Or 4/3 times 3/2. Well, the 3's cancel, the 2 cancel with that, and it's just a 2. So this is x squared plus 2x plus something, and I've got that 1 over here. We'll put that back later. 2/3 is my a. Here I have to take half the coefficient of the middle term and square it. So this is really x square root plus sine 1 square root quantity squared. And that's the same as this. I'm going to put this 1 back here, minus 1. Oh, I'm sorry. If we add 1 inside, multiplied by 2/3, we have to add 2/3 to this side too. So it's not just 1, it's 1 and 2/3. Because this would be a 1 and 2/3 over here. So now we've got the a, 2/3, x minus a negative 1 squared minus 3 or 5/3, we'll call it. So we move it because you can think of this two ways. We're moving a left 1. we're moving it down 1 2/3. And then we're going to make it a little wider with this 2/3 here. So left 1, down 1 2/3. See, it opens up because A is positive and is a little wider. Sort of close to 1, so it's not too wide. Does this make sense? If we look at number 42, f of x is equal to x squared minus 2x minus 3. Now we got to do a bunch of things here. Graph the quadratic. Determine the domain and range. Where the function is increasing and decreasing. And we'll assume those are interval notations. So how do we graph this? Well, what is the vertex? Let's see. We're going to use the minus b over 2a method and then plug it in to get y. The opposite of b is 2. And 2 times a is also 2. So it is 1. Plug in a 1, you get 1 minus 2 minus 3. Or a negative 5 and a positive 1 is a negative 4. We've got the vertex. The y-intercept is easy. Plug in a 0 for x, it's a negative 3. And maybe we don't need to find the x-intercepts. We could, I guess, if we wanted. Oh, which way does it open? Opens because the a is positive, opens up. So, 1, negative 4 in the fourth quadrant. Opens up. The y-intercept is a negative 3, so because of the axis of symmetry, there's a point here also. Okay, so there's the graph. What is the domain? Well, it looks like it's all the reals. If you do that in interval notation, parentheses, negative infinity to infinity. The range, it starts at this negative 4. So this is 1, negative 4. The range starts at negative 4 and goes to infinity. And negative 4 is included. Where is it increasing? From 1 to infinity. Decreasing a negative infinity up to 1. So we can do that quick sketch and figure all those things out. I think with the rest of these, you should be able to figure them out. So, if you have questions, make sure you email me or text me. I guess email is what you've got, and I'll get back to you quickly. Help you with any problems.